Now, let's shift gears from deep sea to the sky. Picture this, a robotic inspector climbing a high voltage tower. Winds are howling at over 80 kilometers per hour, but it keeps going, adjusting sensors, making repairs, all while hanging in the middle air. Sounds like science fiction, right? But it's not. It's real. It's possible because the way these robots are built. Today's field robots are leaving the laboratory. They're going to disaster zones, collapsed buildings, surgeries, even up into the skies. And they're not just assistants, they're saving lives. But let's be honest, to survive in these extreme conditions, it's not enough for a robot to be smart. It needs to be strong, light, and tough as nails. It needs to be built like athletes. That's where Sunrise-Robo comes in. We tackled 3 hard truths about field robotics. Number 1, precision matters. If a robotic arm is off by just 0.002 inches, that tiny error adds up fast. It can mean the difference between grabbing something or missing it completely. Second, weight kills mobility. Too heavy, it burns more power, loses balance, and slows down. Not good when speed and agility are everything. Third, fatigue breaks everything. High speed, repetitive motions wear down regular materials, and when a joint fails in the field, it's game over. So what did we do? We started with Sunrise HollowStruct, our ultralight skeptical frame system. It's built using advanced simulations to place material only where it matters most. The result? Up to 20% weight reduction without giving up strength. Lighter robot means faster moves, higher clamps, and longer run times. Then came precision. We combine Sunrise Machining CNC Machining with Sunrise UltraMetrology. This combined gives us joint with error under 1.5 microns. That's thinner than a human hair. That's surgical level accuracy for robots. Next, we focused on materials. We developed Sunrise NanoAlloy, a next generation aluminum alloy with the nanocrystalline structures. It's light like aluminum, but tough like heavy-duty metals. Our T6 heat treatment, it heats 520 megapascal in tensile strength. That's aerospace-grade strength, now in field robots. Finally, we used Sunrise SqueezeCast. It applies high pressure as metal cools, squeeze out micro defects. The result? 35% better fatigue resistance. That means fewer failures, less maintenance, more uptime. One proof, a coastal utility company deployed a fleet of inspection robots. Everything was fine until storm season hit. High winds and salt spray caused joint failures. The control system worked, but the mechanic gave out. Then they came to us. We redesigned everything. Lighter structures, tight tolerances, tougher materials. The result? The new robots ran 6 months straight through storms, salt, and sun. 0 joint failures. Mission success rate, 99%. And those robots, they're not just tools anymore. They are reliable partners.